Hello, my Math Independent Study student. The objective for this video is to simplify radical expression. Now, before we begin, we are going to review quick. So, if we have the basis m, if we have a monomial have the basis m and the exponent is a fraction m over n. So this is the exponent, and x is the base. Then we can write this monomial with a fraction exponent at a radical of the root of n. So n root of x to the power m, or n root of x of it to the power m. Okay, so this will be our review. So let's go ahead and apply this concept here. So we have n is 5. So I'm going to go ahead and write each one of. So I'm going to go from here to here. So I'm going to start with a radical. I'm going to write them as a fraction exponent. So I'm going to put to the first one. So I'm going to go ahead and write 243. Now, before we can write them at the fraction exponent, what we can do is that why don't we go ahead and just break them first? So n roots, so 5 roots of 243 times 5 roots of x to the power 11 times 5 root of y to the power 8, and then times 5 roots of z to the power 20. Okay, next, 243 is 3 to the power 5. So I'm going to go ahead and 5 roots of 3 to the power 5 times, now x to the power 10, I can write x to the power 11, I can write x to the power 10 times x to the power 1. So we break it down again, x to the power 1, and then y to the power 8, we write them as y to the power 5 times 5 roots of y to the power 3. Now it's very important that you can see that if you have your root and your power, so think about your m and your n, if they be able to divide it out without remainder, then it means that you'll be able to cancel your radical. So next one you have, so here I can see that the 20 will be able to divide by 5, so will be divide out by 5. So I'm going to go ahead and keep it the same. Okay, so now let's write them in a fraction exponent so that you can see. So I run out of space. I think I'm going to go ahead and keep them this way. Sorry, I run out of space. I'm going to go ahead and erase this problem. Then we're going to go from here. So now, which is 3 of 5 to the power of 5. And of course, this will be divided out, so that will just give you 3 times x to the power 10 over 5. Let me write them at a fraction exponent. And here, if you cannot divide it out, I'm going to go ahead and keep them the way it is. So 5 root of x to the power 1 times y to the power of 5 over 5 times 5 roots of y to the power of 3. The reason that I do not write them as a fraction exponent because 3 cannot divide by 5. I mean it will not go. You're not going to get an integer quotient, so that's why we're going to keep them the way it is. And then times z to the power of 20 over 5. Okay, so all of this fraction, it will be divide out. So therefore 3 to the power of 1, which is 3, x to the power of 2, and then 5 roots of x to the power of 1, which is 5 roots of x, y to the power of 1, and sometimes, you know, if your exponent is 1, you really don't have to write this, so you need to ignore this. And then 5 roots of y to the power of 3 and z, so 20 divided by 5 give us 4. So now I'm going to go ahead and bring all of the term or all of the monomials that not in the 5 roots out. So we have 3 x squared y z 4 and the 5 root. Now all of the term inside our radical, we call these are the radicants. We can put them under 1 5 roots, so we have x times y to the power 3. Okay, so this will be the answer for the given expression after we simplify. And thank you so much for watching. Make sure you write out the summary. Goodbye.